It's about contributing to open source project on GitHub. It will work for mainly everything that uses Git, but in my demos I'm focusing on GitHub since the PowerShell team chose to use GitHub as a open source platform, or the platform to host their open source projects. So no, the button is already pressed. We have help for that this here. So community for me is mainly around being able to share experiences with everyone else. And the first time I contributed to an open source project was when the PowerShell team posted their DSC resources on GitHub. And I was very lucky to get a lot of help and have a lot of information exchange with the person managing the project that I was contributing to. So now I'm trying to share my experiences this past year around using GitHub and using GitHub from PowerShell and from the PowerShell command prompt. And this is just that, it's my experience. So anything I tell you, it's not like this is how you have to do it. A few of the commands, well, they're obviously the way you run them, but anything else than that I say is my experience and my opinions. I assume you guys have similar experiences, so if you have anything you feel you want to add, share, or ask, don't hesitate, just interrupt me and we'll discuss it, because that's what the community is all about, right? So on the agenda today, I'm first going through a few slides talking about the concept of contributing to stuff on GitHub. Just trying to explain the process. Then I have a few slides on the Git command line. I feel it's easier to show them in a slide, so I've tried to mimic the command line in the slides, and then we're going to do it live, hopefully, if I get the internet to work. If I don't, I'll have some screenshots and some command line that we'll try.
Tell me, then I can open up the mobile hotspot. Works.
Thank you.
Tested it yesterday.
Cool. All right, so first, I've made this animation on how you can copy repositories on GitHub. So a project on GitHub is a repository, or maybe even before that. How many of you are using version control today? Basically all of you, cool. And how many of you have been publishing anything in an open source platform repository? A few. And how many of you have contributed to someone else's project? Also a handful. Cool. So if you haven't started using version control yet, please look into it. It doesn't really matter which kind of version control you're using, but if you're writing PowerShell project scripts, whatever, you probably want to check out the PowerShell team's open source repositories, and they're using GitHub. So if you use something using Git, you'll have an easier time learning one thing instead of learning several. That's why I chose Git. So, and the first thing, the first major resistance or block that I encountered when I started writing resources or started writing scripts and stuff and wanted to share them was to place them somewhere publicly on the internet. That's kind of scary because sometimes someone might think I'm not doing the right thing, or I might be criticized and so on. And once I got past that, the second blocker for me was contributing to someone else's project, because that's the risk of being publicly denied something or publicly rejected is at first scary, but it's not really a problem once you get used to it. So back to GitHub. On GitHub, on this slide, I'm illustrating GitHub as this blue, turquoise, whatever color is box. And on GitHub, I have my repository that I want to contribute to. So I call this the upstream repository. And we can call it whatever we want to, but I'm calling it upstream because it makes sense later on in the demo. So when I have an upstream repository that I can't write to, I only have read access, I can copy that repository to my own account on GitHub. And that is called a fork. So on GitHub, I can click a button, which is fork. And when I click the button fork, I will create a copy of someone's repository on my own account. So a fork is basically just creating my own copy, and this copy I have full write access to, so I can change stuff and modify and do whatever I want to. Once I have my fork, I download a copy of that fork to my local machine, which represents this larger box down here. And download in Git terms is called clone. So if I do git clone and a URL, I will download a copy of the repository. And once I have the copy downloaded, I can download updates. And I can do that by either using something called fetch or pull. And pull, we just download the difference in changes from the GitHub repository down to my client. And also, when I do clone, I get a reference on my local repository that points to the origin. So this reference is called a remote. It's basically a link to some other repository which I'm copying from. Once I have my copy local, this is just a folder on my computer with some metadata containing all the information about history and who changed what and so on. So once I have that online or offline on my computer, I can change stuff just like I'm modifying files. And once I modify the file, I can add those changes to something called staging. So by doing an add, I'm basically telling my GitHub client that these are the changes in this file that I want to later on save in a future snapshot. And those snapshots in GitHub or in Git is called commit. So once I've added changes, told my Git client that these are the changes that I want to save, I do something called a commit. And a commit is basically creating a snapshot in time. So then I can, at any point in time, go back and see how my code looked at that point in time. So I do this over and over again. So I change stuff, I add the changes, and I commit them. And this creates one or more snapshots in time, which I can move back and forth between. When I'm doing this, someone might update the code in the upstream repository. So the person maintaining the original repository that I forked from might implement the change. And I need to download that change to my local repository because otherwise I run the risk of having conflicting changes, and that will just create a mess once I try to merge them together again. So I need to create another reference just like this one. But instead of pointing to my origin repository, I need to point it to my upstream repository. So this is called a remote, and I add a second remote. And I can add any amount of remotes that I want to, and each remote, I give them a name. And in my demo, I call the first remote origin, because that's the default name that Git will give it. And I call my second remote upstream, and that's why I've named them origin and upstream here. So once I have that remote set up, I can either do a fetch, which will just download all the metadata from the upstream, or I can do a pull, which will download the data and then merge it into my local repository. And this way, I can download changes made in my upstream repository. And once I've downloaded those changes and combine them or merge them with my local changes, I can push that to my origin. And once my origin is updated, I want to ask the maintainer of the upstream repository to please implement the changes I've done in their upstream repository. So in GitHub, I do that by using something called a pull request. And a pull request is exactly what it sounds like. It's a request for someone to pull my code into their repository. So what happens when I do a pull request is that I will have to supply a title and a message, like saying, this is what I changed and this is why I think it's good for you and so on. And then we can have a discussion around my changes, and I can continuously do change, add, commit down here. I can push the changes up to my origin, and as long as I work in the same branch, everything I do on the branch I'm currently working on will be added to my pull request. So then we have the concept of branches, and each repository here is a copy of each other, so they're supposed to look identical, more or less. Obviously, the changes I've done here are synchronized or pushed to my origin, but they're not updated in the upstream until my pull request is approved. So in each repository, we have a bunch of like parallel universes, and these universes are called branches. So every time I want to jump between a parallel universe in a repository, I check out another branch. So usually you have a default branch called master, which is the first branch created in a repository. And then you create another branch called dev or development or something where you actually do your development. And once you're confident that you have a state in your code that you want to create like a production release of, you copy all the changes made in your development branch into your master branch, and that makes up a release. So what's important when I do this like workflow thing is that once I start to change stuff here, I should implement a specific branch just for my changes. And then if I push that branch, so I can call it fixing bug number 2 or whatever I want to call it, once I push those changes up to my origin and create a pull request, everything I add to that branch will be added to my pull request. And once my pull request is approved, it's a good idea to remove that branch from my origin and local branches, local repositories, because then I don't run the risk of adding something to a branch which is associated with a pull request. So, and any questions on the flow part? Oh, cool. So the git command line, I use something called pushgit, and pushgit is a PowerShell module that gives me this nice prompt stuff. So if I load pushgit, and I usually run it in the PowerShell console, mainly because it works best there. So when I load the pushgit module and I have the Git client installed, I get these nice prompt parts every time I enter a repository. So on the first line here, you can see that I'm currently in the branch issue number 1. So this shows me the current branch. And then I have a +1, tilde0, and -0. And these are all reds. So this means that I have 1 file added, 0 files modified, and 1 file 0 files removed. So if I do a git status, I will get a status message telling me these are the files modified, these are the ones added, and so on. So once I'm confident that I want to add something to my staging, I do git add and I just name the file. So this will turn the prompt green because I now have stuff in my staging area. So everything in the staging area will be represented by green numbers. And if I have both stuff in my staged area and stuff not staged, I will have both green and red numbers. So once I have stuff in my staging area, I will do git commit and give it a message. And that message will be the name for my snapshot or my commit. And once I commit it, you can see that all the numbers disappear because my branch is like in consistent state or whatever you like to call it. It's all the changes have been saved, snapshotted, committed. If this is a branch that also exists in my remote or my origin repository, once I do commits to it, the issue will turn in a different color. That means that my branch is ahead of the remote branch. It can also turn green for being ahead. It can turn, I think it's yellow for being behind, and some other color if I am both behind and ahead. So if someone commits something to my remote that I haven't downloaded or merged into my local, and I also commit something to my local, then I'm both behind and ahead at the same time. So let's try this with internet. I'm actually going to try my hotspot here and see if it works.